Here's a video of the levels 3 and 4 for Standard 9. The in-class and homework summative review Standard 9 can be found in the Schoology link. And in this link, we did problems 1, 2, and 3 yesterday, and so we'll continue today with 5 and 6, kind of going a little bit out of order because of the order that they'll show up on the actual assessment. So we'll start with problem number 6. So I'll scroll down here and click into the show your work for number 6. Off to the left-hand side, I do have some little bits of information, kind of some notes, little hints about kind of how the steps are going to go. When you actually get to the assessment for Standard 9, the summative, it will give you numbered steps. So, for example, it will have 1, 2, 3, 4, 5, and then this one is actually going to have 6. And then it's matching 1, 2, 3, 4, 5, 6 will be over here on the other side. So this is going to have 6 steps. First thing I got to do is get my first given into the proof. So that first given is LE is parallel to RA. And those are segments, so there should be bars over the top, but for time's sake, I'm going to go ahead and keep going. That's by given. Now, because we have parallel lines, and this is something we talked about when we discussed the first 2 problems, because this is parallel lines, then my next step is going to be one of the following. Now, we're getting into where you can see triangles in the figure. The last 2 problems that we did for Standard 9 kind of look like a tic-tac-toe board, where 2 lines were intersecting and they were both 2 sets of parallel lines. This looks a little bit different. It's triangles put together either in this bow tie or hourglass shape, or there's going to be, it looks like a rectangle or some sort of quadrilateral. So when you have parallel in one of these types of triangle looking problems, most likely you're going to be using alternate interior. Okay, and that's exactly what we have here. My lines that are parallel, just like I said yesterday, it helps to highlight them. So my lines are LE, which is this line down here at the bottom, and RA, which is this line here at the top. There's actually 2 sets of alternate interior angles, angle R with angle L, or we can choose angle E with angle A. Okay, I'm just going to do R and L because that's the one I did first, so I'll keep that one around. Okay, so let's get that into our proof. So angle R is congruent to, I'll go ahead and get my congruent marking out here so I can just continue using it. Copy that so I can keep using it for later. R goes with angle L. And that is alternate interior angles theorem. Okay, now I, a lot of times, have to remind myself, so I can put that all the way here at the end, to mark it. I tend to have a tendency to get excited about things and then I move on to the next thing without marking it. So angle R and angle L, mark those. Okay, so that's my first set. Now there's nothing else I can do with that, so now I move on to my second given statement. So my second given statement is going to be the T is a midpoint of RL statement. So RL is this line here, starting at R, ending at L. So I'm going to have 2 tick marks on either side of that point T. So point T to the left, I'll put a tick mark, and point T to the right, I'll put a tick mark. That's what I'm going to say by this definition of step. Okay, let's not get ahead of ourselves there. We still have to put given there, and now I'm ready for this next step, this definition of. So my definition of, this is where I'm going to go ahead and say RT is congruent to, I'll paste my congruent in there, congruent to TL or LT. And that's by definition of a midpoint. And I already marked that, so I don't have to tell myself to mark it. And because we are trying to see if these triangles are congruent, all triangle proofs have one thing in common. All of our triangle proofs had a vertical or a reflexive step. This one, because it looks like an hourglass, is going to have vertical angles. And those vertical angles are going to be the angles at T. So sometimes we like, some of you like to just put a dot here if you're going to mark them, and then use those 3 letters. So I'm going to practice using those 3 letters again. We haven't done that for a while. So we'll go angle RTA is congruent to angle LTE. Vertical angle theorem. Okay, now that I have all the markings on my picture, I'm going to look at those markings to determine why the triangles are congruent. Okay, so this step 6 here, we're going to look at the markings. We'll look at the markings in one of the triangles to determine why they are congruent. So I need one of my triangle congruence criteria. And then my options, again, are side, 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 angle, angle, side, angle, 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 side. And then, of course, HL, but there's no 90 degrees here, so HL, which one works, okay? So if you look up here, we have a set of angles marked. We have a side marking, and then we have another angle marking. So my criteria is going to be angle, side, angle. Then for my triangles, we'll go triangle, and we'll copy this, RAT is congruent to triangle. I'm just copying this from the proof statement, triangle LET. Take a second to pause the video if you need to before you move on to the next proof. Before we start this proof, on the left-hand side here, I've taken a minute to go ahead and put in our different kind of hints or steps. So if you need to pause and you want to write those in before you start, you can, or if you want to write them as you go, you can do that as well. So number 1, we are going to write the first given into the proof. Then we'll jump into number 2, where we use our alternate interior, most likely. Number 3, we'll jump into our second given, which this time it's not a vocabulary word, definition of, or anything like that. It's just a straightforward statement. Then we'll do our vertical or reflexive step. We'll be ready to prove that the triangles are congruent next, but then this is where we're going to add on to get our level 4. So to get level 4, we are going to have a step after the triangles are congruent to get congruent angles, and then we'll be able to actually write in our proof statement at the very bottom. So this is a 7-step proof. So I've got my 7 steps in there. Let's get started with that first step. So in my first step, I'm going to go ahead and put GO is parallel to AT. That is given. Okay, there's nothing to mark there, but because, and this is in orange there, because we're given parallel, the next we need is alternate interior. So if I'm looking up at my picture here, which alternate interior? There's actually multiple pairs of alternate interior angles. So I'm going to start by taking and marking the lines that are parallel. So my 2 parallel lines are those lines GO, so that's this top line here, GO, and AT. Those are the given parallel lines. So hopefully by now you know, and if you don't, that's okay, that's why you're watching this video. What we need to do for our congruent angles here is we need to start at the line that's parallel and go into the transversal. So if I start down at the parallel line here and go into the transversal, that is my first congruent angle. That angle right there is congruent to, now go up here to the purple line and mark from there down to the transversal, and that is my second congruent angle. So if I go ahead and write in there a 1 for angle 1, that's really tiny, and a 2 for angle 2, there I have marked my 2 angles, and I can use that, or I can use my 3 letters like I normally do. So you can use numbered angles if you put the numbers on the angles, or you can use your 3 letters. I'll go ahead and use the numbers just to kind of show that. So my second thing is going to be, my step 2 is going to be angle 1 is congruent to angle 2. And those are alternate interior angles, and we used the theorem to say that they were equal to each other. And the same thing that I wrote before, I don't know if you're as bad about it as me, but I get so excited because I'm ready for the next one and I'm just keep rolling, and sometimes I forget to mark it. Now those are already marked for me, so I can go ahead and move on to the next step, which is my next piece from the given. So I've got angle O is congruent to angle T. Now that has no vocabulary, so all I need to do is go up to the top and mark it. Okay, so make sure that that gets marked up in your picture. So we'll go ahead and put an arc mark on O and T. Actually, let's do a double arc, just because our single arcs are already in use. Okay, so now I've got 2 sets of angles. So when I prove my triangle's congruent, I've got 2 angles and probably a side. So it kind of takes my criteria down to either angle, angle, side, or angle, side, angle. Those are really my only options since I already have 2 angles in my picture. The next step, step 4, does say that we need to use either a vertical or reflexive. So because these share that line that goes right down the middle of the proof, we're going to use reflexive, which is GA and GA or AG. The triangles are now congruent. So that's triangle GAT is congruent to triangle AGO. And then when I mark my reflexive, that is going to be angle, angle, side there. Okay, and then my last 2 steps, here's where it comes in, it's a little bit different. You need to do a CP/CTC to prove that angles are congruent. The only angles that are not marked already in the picture are angles TGA and angle OAG. Now I'm able to go ahead and state that my lines are parallel by converse.